Let's get started with the presentation. Good afternoon, everyone. My name is Benjamin Rosas, and I'm here on behalf of Rheonics. Well, it's my pleasure to be at this event with you. Today, I will be presenting what are inline viscosity and density sensors for the mining industry and the benefits they can offer in terms of optimizing the different processes within this industry. Here we can see a brief overview of the agenda, which has been divided into 6 sections. First, we will talk a bit about the introduction to Rheonics, who we are and where we come from. Then we will move on to our sensors, the electronics that make them up, and the integration with different systems or communication protocols we have available. Once we've covered the information about Rheonics, we will talk about the relevant measurements for the mining industry and also the main applications in which our sensors can be used within this industry. We will finish with real installation examples so that you can get a better mental picture of how the sensors are installed and the versatility these sensors also offer for different applications within this industry as well. All right, let's start by talking about who we are and where we come from. We are Rheonics, a Swiss company that is just beginning to establish a presence here in Peru. Rheonics was born, or was essentially founded, out of the need and the lack of robust, easy-to-install sensors, what we commonly call in English plug-and-play, for real-time viscosity and density measurement. These sensors are installed inside pipes, tanks, recirculation lines, bypasses, etc., in any type of installation necessary to obtain real-time measurements. To achieve this goal, the founders essentially brought together a group of specialists from different leading companies and top-tier universities to work together and develop our sensors. We operate globally, but our headquarters is located in Winterthur, Switzerland, and we also have a presence in Sugar Land, Texas, in the United States. Allow me to briefly present the history of Rheonics. It all began in 1985 with the patented design concept of the sensors conceived by our founders. A few years later, the first laboratory viscometer was developed, which then led to an inline viscometer, and ultimately to the formal founding of the company in 2012. Thanks to Rheonics' commitment to continuous improvement and constant innovation, we have earned various certifications as well as international awards such as the Swiss Excellence Award, FDA, and ERA Technology of the Year. In terms of certifications, we have 3 main groups: certifications for hazardous environments, ATEX, sanitary hygienic certifications, and quality certifications. Our history, as you can see, is fairly long, but it hasn't ended there. Our innovation keeps growing and we continue developing new solutions for our clients, adapting to the applications and the different types of environments to which the sensor may be exposed. Continuing with the industries where Rheonics is present, as you can see on the screen, you can also scan the QR code if you're interested in learning more about this. We have a presence in virtually every industry you can think of: mining, food and beverage, pharmaceuticals, automotive, paints, inks, etc. There is always a Rheonics sensor installed in these industries. Regarding our products, the main ones are the SRV, an inline process viscometer that delivers viscosity and temperature simultaneously with a single probe, and the SRD, which shares the same characteristics but also measures density in real time for different applications. We also have other products such as the DVM, DVP, and RPA, which are for more specific cases, but today we will be focusing on the SRV and SRD, which are the main products for the mining industry. As you can see on this map, Rheonics' presence is global. We have partners, projects, and clients all around the world, throughout Europe, Asia, the Middle East, Latin America, North America, and beyond. The process we carry out is, we go in, install the sensor, and obtain real-time measurements. As you can see, the sensor has been exposed to different types of environments, demands, and applications, and we take all that information and make it available to all our clients. This is what we all call a sensor. It consists of 3 main parts. First, the sensor electronics, the sensor cable, and the sensor probe. The probe is the element that will always be in contact with the fluid to obtain real-time measurements. The electronics handle translating those real-time measurements into viscosity, density, and temperature. The cable is essentially what I like to call the connection bridge between the electronics and the probe. Let's move on to look at the operating principle, which is something very important for our sensors. Rheonic sensors work under a patented technology called the balanced torsional resonator, which essentially oscillates at a high fixed frequency. When this oscillation comes into contact with the fluid, as you can see here, the tips oscillate in the graph. That oscillation changes, and the variance generated is what we measure. Using patented algorithms, we use it to obtain viscosity, density, and temperature measurements. Another important point, as you can see in these images, there is a red shaded zone. This red shaded zone is essentially what we call the sensing zone. This sensing zone must always be in contact with the fluids to be measured, free from deposits, and always exposed to the flow. The sensing zone differs between sensors. For the SRV, it is 16 millimeters in diameter by 50 millimeters long, and for the SRD, it is 35 millimeters in diameter and 50 millimeters long. Allow me now to present the Rheonics SRV. The SRV, as I mentioned, is an inline process sensor/viscometer, lightweight, compact, and hermetically sealed, for applications where viscosity and temperature need to be measured in real time. This sensor also has an internal mathematical engine that allows us to calculate temperature compensations for viscosity, which can be very important for some application cases. This sensor also has a modular design, making it compatible with different types of process connections and different insertion lengths, so we can adapt to any type of installation needed, whether a long flush mount or short installation in tanks or pipes. Its design also makes it easy to clean, and it does not require maintenance or recalibrations throughout its service life. Some clients, due to internal quality certifications within their company, do verify this calibration annually or every 18 months, but from our standpoint, it is not required. Additionally, the sensor comes with multiple types of accessories designed by Rheonics, compatible with both the SRV and SRD probes. Here you can see the viscosity range, viscosity accuracy, and reproducibility that our sensors offer. Moving on to the SRD, it is essentially the sibling. It belongs to the same family as the previous sensor. The only difference I mentioned is that this one allows us to measure density in real time, which enables measurements of concentration, dynamic viscosity, and kinematic viscosity. This sensor is also compatible with multiple process connections, different insertion lengths, and the various types of accessories we offer from Rheonics. As you can see, its viscosity range is quite high. We can measure practically from gas up to 4 grams per cubic centimeter, and the precision and reproducibility of both the SRV and SRD are high. Now let's talk about the mechanical aspects of the probe. It looks a bit large here, but unfortunately I haven't brought a sensor with me right now. However, if you could compare it to the palm of your hand, the sensor, as I said, is quite small, roughly the size of your palm. It is compact and lightweight compared to other types of sensors on the market. The material of this probe can be manufactured in 316L stainless steel, which is the material type that suits most industries, but if you have a more corrosive environment, such as handling acids, etc., we can offer the sensor in Hastelloy C22, a material more resistant to chemicals. The sensor's temperature range is rated for temperatures between minus 40 degrees Celsius and plus 285 degrees Celsius. Here, thanks to my team who just brought me a sensor, as you can see, it is a small, compact, lightweight probe. It weighs nothing, really. This is what we call a sensor built with technology and innovation. Currently, this sensor or probe, depending on the variant used, can withstand up to 1,500 bar or be exposed to up to 20,000 psi. One more thing I forgot to mention. Due to the balanced torsional resonator technology we use, these sensors are not affected by external vibrations. This allows us to install the sensor even under non-ideal measurement conditions and still obtain very stable viscosity, density, and temperature readings. Let's move on to look at Rheonics certifications. As I mentioned earlier, we have 3 types or 3 major certification groups. First, for explosive and hazardous environments, we hold ATEX, IECX, JPX, and KCS certifications, the last 2 being regional certifications for Japan and Korea, respectively. ATEX is for Europe, and IECX is more widely used in the Americas. In terms of quality and conformity, we have ISO 9001 and CE certifications, which support our high standards and manufacturing designs in accordance with these regulations. We also have sanitary/hygienic certifications such as 3A and EHEDG. While these are not as directly relevant for the mining industry we're discussing today, they are important because they demonstrate the versatility of our sensors to be exposed to all types of conditions. Now, having covered the sensor, let's move on to look at the electronics and integration. First, we will look at what is basically the electronics, also referred to by its acronym SME, Sensor Module Electronics, which is essentially the brain of the entire sensor. This is the element responsible for obtaining measurements and transforming them into viscosity, density, and temperature in real time. Something to clarify here. From the different variants we have, as you can see there are 4, they are all the same internally, but they come in different housings. For example, one comes with an IP66 rated protective housing and also has an integrated display to view viscosity, density, and temperature data in real time at the installation site. Moving on to power requirements, the sensor is quite easy to integrate. It only needs a 24-volt DC power supply and a minimum power of 10 watts. Additionally, we can see that the sensor connection is color-coded. This is part of its simple design, and its main objective is to make installation as straightforward as possible with minimal errors, also avoiding downtime within the plant, factory, or process where it will be installed. In terms of communication protocols, we have different types available. You can scan the QR code on screen if you'd like more information. The sensor is compatible with both analog communications, such as 4 to 20 milliamperes, and digital protocols such as Profinet, Profibus, Ethernet, among others. Natively, the sensor supports standard industry communication protocols, and we also have different types of communication protocols via external converters. We also make available to all our clients a wide variety of installation and integration examples with different control systems on our website and support portal, including with PLCs, which help determine success across different types of installations. Now let's look at the main applications. In flotation and separation, sensors can be used in both feed and discharge lines or inside flotation cells. As I mentioned earlier, the objective is to control viscosity and density, manage mineral pulp input and output, and stabilize the flotation froth for better mineral recovery. In leaching and acid management, the sensor can be installed depending on the type of leaching being applied, static or dynamic, in lines for static leaching or in the tank itself for dynamic leaching. Due to their versatility, the sensors can be applied in all types of installations: pipes, tanks, recirculation lines, and others. This can help optimize retention time and reduce leaching cycles. Speaking of thickening and hydration, sensors can be installed in thickener feed, overflow, and discharge lines. One of the most important things to measure here is the flow rate of both the mineral pulp and water. This helps achieve a higher recovery rate for both resources. Additionally, sensors can be installed inside the tank and used to measure different sedimentation levels, allowing us to optimize recovery of both resources. For example, using it as a density sensor, we can measure different sedimentation layers and determine when the final sediment has reached the appropriate concentration to move on to the different tailings and waste management processes. This can also help improve thickening control and optimize the energy consumption of recirculation pumps. It can also help identify and optimize water recovery from tailings by identifying different levels within the tailings with the sensors. Finally, let's look at grinding and classification. This is a very important process because it also determines the success rate of the downstream processes, such as flotation, leaching, and others. Here, the sensor can be installed at the output of hydrocyclones, both at the underflow and overflow, to control the pulp output and know the concentration of mineral pulp exiting the hydrocyclone. Additionally, we can control the addition of wetting agents and lubricants for heavy machinery. Now that we've talked about how rheonic sensors can help in different types of mining applications, let's look at some installation examples. I like to say that the sensor is basically like a watchdog, always watching and analyzing your process 24 hours a day, 7 days a week. For closed tanks, you can see that the sensor can be installed on the roof, at the bottom, or on the wall of the tank, using process connections, or 3 types of process connections you may have. If your process connection is not standard, you can also discuss it with the Rheonics team. The red section shows that the water level, pulp level, or mixture level being measured must completely cover the sensor's sensing area I mentioned earlier. This ensures consistent and adequate measurements for the processes you want to use. We can also see different types of sensors, such as a long insertion probe, which is used for installations from the roof of tanks or larger pipes. For open tank installations, mounting accessories are generally used. As you can see here, this is a mounting accessory designed by Rheonics called Mounting Kit 1, which places the sensor on the side of the tank and allows adjustment of the sensor's immersion depth at different levels. For example, if you need to measure a higher or lower sedimentation point, you can adjust that variability with a long insertion probe, as shown in this image. Now let's look at pipe and accessory installations, something we see practically every day within Rheonics. It is actually one of the most common installations we encounter in our day-to-day work. We have installations both in parallel and perpendicular orientations. For parallel, we can use accessories such as the IFC 34N, a 90-degree elbow, or a sweep elbow. For perpendicular installations, we can do it before or after the pump. As I mentioned, our technology allows for this type of installation without needing to add anything extra to control motor vibrations, as the sensor is not affected by this type of external effect. The accessories designed by Rheonics, for both the SRV and SRD, are exclusive for use with each of them and ensure that the sensor remains completely immersed in the fluid throughout the entire process. Finally, let's look at installations in ponds or pools. This is a somewhat special case that is actually one of my favorites and one I've had the opportunity to work on personally. What we did here was install the sensor in a lithium brine evaporation pond, where it is important to determine the density and concentration levels of the brine at any given moment, because the quality of the final product, in this case for lithium batteries, depends on it. The sensor was powered by a solar panel, and the real-time data obtained from each of the ponds was sent to the central headquarters via a Starlink antenna. The client in this case was in Chile, and the data was sent to their central office located in the United States. These types of installations are customizable by Rheonics. As I always say, we focus on meeting client expectations and finding solutions for whatever type of installation they may have, no matter how demanding or complex it may be. We can offer a solution for you. This is a message I would like to leave clearly. It is something we offer and are always committed to, improving our products and improving the processes of our clients at all times. That has been my presentation. I hope you enjoyed it. Thank you very much. Here in Peru, we have our legal representative with Guessman and global support throughout Rheonics. Thank you.